Hi all, welcome to part 3 of the video lecture on notion of efficiency on the course algorithm analysis and design. So in the previous two parts we saw how to basically how that comparison can be done. I mean the efficiency, how we can come up with the efficient algorithm, or what is the way in which you can measure the efficiency of an algorithm, right? The time as well as space efficiency we saw, and this time complexity analysis, we saw a particular method called a step count analysis. So that is what we explored in the last two video, and some case studies also we saw. Now this is something I taken from the textbook for a very formal way of introducing you that step count, the concept of step count. Let's see how it is done in a formal way, but in a very informal way I explain that step count concept. You can follow that, that is fine, because it is not like this has to be done this way. There is nothing like that. Basically you are supposed to count the fundamental operation, or the how frequent some operations are getting executed in the algorithm. So that is how you are expressing the algorithm time. Okay, so the time taken by the algorithm, or how you are analyzing the execution time. So then now let's see this example or the step count analysis in a very formal way, as explained in your Corman textbook. So this is they taken this insertion sort as an example, and I just want you to recollect this, how this insertion sort algorithm is working. Hope you remember. Suppose you have something like some array, say some elements, say 10, 5, 7. These are all the elements you want to sort out, okay, to some 8, like that, randomly begin. So what is happening in the insertion sort, you will virtually divide the array into a sorted and an unsorted list, okay, so that when you are taking a single element, you know that by default it is sorted. Okay, so it's just like this, how we are sorting the cards. So that is the way it's happening. So first one, you assume that it is in the right position, okay, in the array. Now the second one onwards, so that is why we have a for loop that varies. The array index, we are assuming that it is starting from 1 2 3 like that. So our index variable j is going from 2 to n. Okay, so j is initially holding here, and it will go up to this, and in every iteration it will pick on element from the. So this is something looking like an unsorted array, right? Unsorted array, or unsorted part of the array, and this is something sorted in the sense, as I have a single element, by default it is sorted only. Now we are trying to expand this sorted array by picking each element from the unsorted array and inserting it at the right place in the sorted array. So that is the idea. So initially this is j equal to 2, right? So at every iteration the key will contain this jth element. Okay, so initially this this key variable key will be containing this 5. Okay, so the a of jth element. Now there is a command line saying that insert a of j, I mean this 5, into the sorted sequence, that is from 1 to j minus 1. So initially this j is 2, so 1 to j minus 1 is just a of 1. Okay, so from I mean in this, so this is a sorted part of the array, right? So insert the first element of the unsorted array, which is currently we are having, into the right place in the sorted array. So that is what is happening. So that is the logic. So how you will insert this 5, you can see that this 5 is to the left of 10. Okay, so you will compare this 5 with the 10, and you saw that this 10 is larger than 5, so that you will shift this 5 to right, and you will make a space for this 5, and you will insert it. So that is the way you are doing it. So after doing it, let me tell you the array in after one iteration. Okay, so it will be something like 5 10, and so that this 7 12 2 8, they are in the unsorted array. Again you will pick this 7, and you will insert this 7 at the right place here, so that you can see that this 7 is actually between this 5 and 10. And let's see how this is to be done. Okay, so this single element is difficult to explain, that's why I go on to one more iteration. Okay, so now your key value is containing in the so in the second iteration j will be 3. Okay, so and the key value you will copy this 7, a of 3. Okay, now you in the for index in the sorted array, so this is a sorted array, we are using index variable I, and the initial value of I is always I is just back of j, right? I start from here, and I will go like this. So the initial value of I is 2, and that is nothing but j minus 1. Okay, fine. So after that, you know, in every iteration you will see whether this I is reaching at the leftmost end. So whether this I is greater than 0, then you can proceed. So here this I is 2, it is greater than 0, I is 1, this is also greater than 1. So like that you can proceed backward. Now in every iteration you are doing this checking, right? Whether a of I is greater than key. So this is your a of I, right? A of I greater than key. So this is a checking I am doing, and I know that this a of I is 10 and my key value is 7, and I know this condition is true initially. If this is true, what I will do, I will put this a of I at one position right. That is, a of I will be moved to a of I plus 1. So that in the next position of the array, this is the first position of the array, second position of the array. Initially 5 was here, 10 was here. Then at this place, this 10 will be moved. So, okay, so this is where your I is pointing. Okay, so from this position, hope we get it right. So your I is pointing here. A of ith element I moved to a of I plus 1. So you may think that what about this 7? 7 is not going to lose, because 7 you are already keeping inside the a different variable, that is key. Okay, so 7 is safe there. So this 10 I moved right. Then I decremented this I value, so that I value will be coming here. Okay, so I will be 1, so that in the next checking what I will do, a of I greater than key, I will do that checking, and I can see that when I is reaching here, a of I is 5 and 5 greater than 7, this condition is false. So when this condition is false, I will just come out from the loop. Okay, and I will do this. Okay, so hope it is clear. So that what I will do is, current value of I is here somewhere, so a of I plus 1, I will insert the key, so that this key will come here. Okay, and this 5 will be safe over here. So that about it. Now the unsorted list will contain this 12, 2 and 8. And again you will take this 12, and hope you got the idea. Okay, so if this 12 is coming, you compare with the 10, and that time itself the condition will be false. You will come out and you will place 12 there itself. So this is the best case. You don't have to go backward. Just with a single comparison you are fixing the position of 12. Then when you are taking 2, that is a worst case scenario. Like this 2 will be compared with the 12, 12 will be moved right, then 10 will be moved right, 7 will be moved right, 5 also will be moved right, and at the beginning this 2 will be placed. Hope you get it right. So that is a way. So like that the algorithm will proceed, and hope you understand the algorithm, and this is something you already studied also. I just repeated, just want to make sure that everybody is able to follow it. Okay, so that about it. So once you know this algorithm, actually at this point the explaining algorithm is not what I was supposed to do. I was supposed to analyze the algorithm with the hope that you already know it. Anyway, I explained also. Now I think let me proceed to analysis part. So when it comes to analysis, you can see that the very first line where this j is executed from 2 to a dot length. Okay, so let's assume n is the size of the array, or a dot length. Okay, so that is a default assumption we are having, so that this line is getting executed. How many times this line is getting executed? Some array size is n minus 2 plus 1 times the condition is getting true, and one more time where the condition is getting false. Okay, so that if it is false, that time also that comparison will happen. Okay, we are not focusing much like assignment, increment and comparison. We can just focus that comparison as a dominant operation, because that is getting repeated more, right? The false case also comparison is there, but assignment and increment are not there. So that is a dominating one. You can see that. So this is what this is n number of comparisons are there. Okay, so by taking it as a default, the basic operation. Okay, whatever be, we are not focusing particularly about the operation. We are just saying that n operation. Okay, so that is being executed n times. Now for executing it one time, what is the cost? And that I don't know. I am simply taking it as C1. Okay, I am saying that the cost of executing line number 1 for one iteration is C1, and it is repeating n times. So totally it is getting executed. The total cost of this particular line will be n times C1, something like that. Okay, and what is this C1? C1 is here, according to my example, if comparison is a dominant operation, then C1 could be the time taken for comparison. Okay, and that is something platform specific comparison, specific to architecture. Okay, let me write like that, specific to machine. Okay, something like that. So that I don't have to worry about. I will just assume that it is taking some constant amount of time, and that I don't know, let it be some C1. That is specific to the architecture. I am leaving it up to the architecture. So that about it. So the hope it is clear. Now about the second line here, you can see that just an assignment statement. Again, the time taken for that assignment statement, I don't know. I am taking like it is C2. Okay. And it is getting executed n minus 1 times. Why? Because it's inside this loop. So that is why this outer one false case also will come, but inner one it will execute only if the condition is true. Now here I have a command, so this is a command line, so the cost of command line will be 0 because it's not going to be executed, you know. So this is the command line, so no execution for it. It is simply for understanding purpose. You are not going to execute it using the platform, so the cost will be 0. And you know, it is also written inside this loop. So what I was doing, let it execute n minus 1 times or more, whatever it is, its cost is 0, fine, right? Now once you come out from the loop, so it's not still you are inside the loop only. Sorry, this loop is starting here and it is ending here only. Okay, so still you are inside the loop only. So that is why every line is inside loop, so all are getting n minus 1 times like that. Okay, so now this line also executed n minus 1 time, and in every time some decrement, some subtraction as well as some assignment is happening, and the cost of subtraction as well as assignment together, let it be some C4, I don't know. So I don't have to worry about whether it is comparison or assignment. If you are doing that way, that also fine, because previously I shown you like that. But this is a more abstract way. I am simply assuming that the total cost of this comparison and this decrement subtraction operation, it's C4, some C4, some constant. Okay, fine. Now you can see that this is slightly tricky in the sense, here we are having on what I can tell you. This while loop is getting executed inside the for loop. Okay, so for loop with every iteration, that is when j is equal to 2, some number of times this while loop will execute. When j is equal to 3, some number of times this while loop will execute. J equal to 4. So for every jth iteration, this loop is going to be executed some number of times. So that I don't know. So let it be some tj. Okay. And you know what is happening inside this while loop, it is actually trying to fix the position of this key, right? So this inside while loop is doing this backward search. So it will compare with 10, then shift to 10, then it is placing 7 in between. But when it comes to 12 and all, it is doing just a single comparison, it is coming out. When it comes to 2, it is taking more cost, right? Every element 12, 10, 7, 5 all are small, bigger than 2, all get right shifted. So that many comparison and that many right shift. So that is about the j value. Okay, so for when j is equal to 2, depending on the element a of 2, some number of comparison will be involved. So let it be some tj, we don't know. Again we are taking like a we are leaving it to the outer loop. So for a different value of j, some t2 number of times, some t3 number of times. So basically it is constant only, but it is varying. Sometimes it will be more, sometimes it will be less. Anyway, some iteration, some time it will take, and we can do this minimum time as well as maximum time analysis. Sometimes this is one case where just a single comparison is needed. This 2 is another case where some it is getting compared with all the remaining n-1 element. Okay, so the first one I explained is a best case, right? Just a single comparison, you are fixing the position, and the case of the 2 is actually worst case. Many comparison you have to do, many right shift you have to do, then only you can fix that too. Okay, so both we will analyze separately. So accordingly we have the best case analysis and the worst case analysis, and in between some average case analysis also. That is the whole story. Okay, so hope you get it. So that is why this while loop. So what is this tj? Tj means for a specific value of j for the outer for loop, how many times that while loop is getting executed. So that depends on that outer iteration and the particular element at a particular value of j. Okay, and now this you have to sum up, right? Because all together when j is equal to 2, some number of times that while loop will execute. When j is equal to 3, some number of times that while loop will execute. Okay, so it is something like so I'm not going to write it, it is self-explanatory, right? So when j is equal to 3, some number of times, etc. When j is equal to n, the length of the array, this while loop will execute some number of times. That I don't know. So that I am taking like a t2, t3, t4, like that it will expand. Okay, that I am adding together, and that is the total time. and the total number of times it is getting executed, and the cost of each line, let it be c5. Again, this cost is actually this a of I greater than this comparison cost, as well as this comparison cost, as well as this and operation cost. Okay, so some logical operations also involved. So altogether, let it be some c5. Now if you are looking at this line, this is inside this while loop. So this while loop tj I am taking for the true as well as a false case, but inside the while loop it will execute only true cases. So one case you can remove. That is why this is tj minus 1. This line also tj minus 1, and the same summation. Now this line, this 8th line, is outside the while loop, this while loop. That's why but it is inside the for loop. So it is getting executed n minus 1 times, and the cost of each line, like some incrementation, some array access, some assignment, all those things are coming. Let the total cost be some c8. Okay, hope you get a feel about how these things are written, and this is a very nice way of doing it, a more systematic way. What I given is a in the previous video is a very vague way, but this is more formal and systematic. Okay, it's always better to go with this way, but for a given case, maybe time related issue or some other issue, you can go for the way which I explained also. That also fine, but this is how the key and all will come, especially if the same question is asked. Okay, so now the total cost will be, you just multiply, add together, like c1 into n, c2 into n minus 1, 0 into n minus 1, c4 into c5 into this one, like that. You will get this bigger expression, simply the sum of the products. Okay, now let's see the detailed analysis, that is the best case analysis, worst case, and average case. So you can see that the best case of this insertion sort will occur when the array is already sorted. I will tell you why. Because if the array is something like 10, 20, 30, 40, 50, you just tell me how this logic is working. You are dividing initially like this is sorted, this is unsorted. Now you just will take 20, and this 20, that is a of j, which is in the key, you will compare with this 10, right? In the first comparison itself, you understood that it is already in the right place. So you are not going to do any shift and all. Simply you will place 20 there itself, and you virtually expand the sorted part, right? 30, 40, 50. Now again you will take this, so you will just do a single comparison. 30 you will do this comparison, and that time itself you understand that condition will violate, it will come out from the loop, while loop. That is what is happening. And this 20 will, and 30 you will keep there itself, right? Then you proceed with the 40. So like that, what I am trying to say, that in every iteration when j is equal to 2, right? So when j is equal to 2, this t2 is found to be just 1. Just a single comparison. How many times that while loop get executed? Okay, so it is get executed only one time. Even two conditions and an AND operation is coming, I am just counting it as a single one. So the total cost of the whole thing, we given some constant here, right? The c5 is there. Okay, so that is taking the cost of the comparison, two comparison and that AND operation. But anyway, it is getting executed only one time, right? So that is what I want to know, want to highlight. Okay, similarly, when j is equal to 3, this t3 is also found to be 1, and then this j is equal to 4, this t4 also find to be 1. So in general, the thing is that this tj is equal to 1, tj is equal to 1 in best case. So this is very very important observation. Okay, so what I can tell is tj is equal to 1 in every while loop. Okay, so this tj everywhere you can replace with 1. So that is very important. When the input is already sorted, you can see that in every iteration, that inner while loop is just executed one time. With that, this condition will violate, and it is it clear, right? So it is just executing one time, and the condition will violate. This will be false after a single iteration, because you know that 10 then it was 20, 10 greater than 20. So this condition will be false, like that 20 greater than 30. Okay, so is it clear? So that will be executed for one time, and it will be false, it will come out. Okay, so that is why the tj is getting 1. So now you can write this tj is equal to 1 everywhere. So here what I am having is summation from 2 to n tj, I mean, which is 1. Okay, so this will become summation from j equal to 2 to n, just 1. Okay, so that is equal to this 1 plus 1 plus 1 plus etc plus 1. How many ones? J is equal to 2 to n, right? 2 to n. So n minus 2 plus 1. So this will execute some n minus 1 once, right? So this is fully n minus 1. So C5 into n minus 1. You will get this term. Similarly, C8 into, so here this is like a Tj minus 1. Tj minus 1 means Tj is 1. So Tj minus 1 is 0. Means inside that while loop, that body is not executed. Okay, so while loop only that false condition it will execute. These two lines will not be executed. So that is why this Tj minus 1 becomes 0. So the this whole thing becomes 0. Similarly, here also this will be 0. Okay, and this will exist. So only this term you have to consider next. So now what we done is all the constants we group together, like all the terms with the n we group together. The C1 will come, right, then the C2 will come, then the C4 into n that will come, and C5 into n that will come, and C8 into n that will come. Okay, and then all the remaining constants also you consider, like minus C2, minus C4, minus C5, and minus is taken out. So it's something like that. So you can see that some constants are getting added, right? And finally you will get another constant, right? So let me write the whole thing. Just like some set of constants getting added, and you will get a different constant, say A, and here also the minus whatever it is, that is also a constant, right? So here you are getting some other constant B, like that. So A n plus B. So this minus I taken inside as a different constant. Okay, so that the whole thing you can write like this. The running time is something like A n plus B. Okay, and if that is the case, you can see that this is something, this constant term as well as this coefficient typically we ignore, and we write it like some order of n. Okay, some linear function of n. I got a linear function of n. Don't worry about this notation, that we will see. Okay, I got a linear function of n. Okay, it's a polynomial of degree 1, like that. Fine. So the best case running time of the insertion sort is found to be some linear function of n. Now let's analyze a worst case scenario. Okay, now let's see the worst case scenario. So here I just want to take an example to tell you why this Tj is equal to j. That observation is what we need at this point. Yeah, see what is happening here. Let me take this. So you got the idea. So basically you should know how that algorithm is proceeding, then only you can understand the analysis. Okay, so let's take so here it's written clearly the worst case scenario is occurring when the algorithm is reversely sorted. I mean, just I am having what just opposite of what I am expected to have. For example, like some 50, 40, some 20, 10 and 5. I just want to sort it in the increasing order. So that first I will do like this. Okay, so that is 50 is sorted. Fine. So from this unsorted part, unsorted, there is no strict classification, that virtual meaning. Okay, so this 40 I will take, this is my current value of j will increase like this, and 40 I will call as a key. Okay, and then here I will compare with this 50, and you can see that that condition is true. I will go inside that while loop, and this 50 will be shifted right. So 50 will come here, and this at this place I will decrement further, and that time condition will be false, and I plus 1, like that I will insert this 40 here. Then 20, 10, 5. Then again when I am taking this 20, so what I was trying to say is at this point how many times this 40, I mean this particular, I mean j, at this point this j is equal to 2, right? So T2 is found to be just one comparison, maybe one more where I am reaching the leftmost point. Okay, mainly the element wise comparison only one. Then I am shifting, and I find out like this is the right place for some minute time extra is involved, but in a overall way I can say like that. But when it comes to 20, you know, 20 get compared with the 50, and that will be shifted right. 50 will come here, right? And then the same 20 will compared with the 40 also, so that this 40 will also shifted, and at this place this 20 will be placed. Okay, so that you can, here you can see that this T3 is found to be 2 times. Okay, comparison, and then 10 and 5 will come here. Now when I'm taking this j key element as 10, you can see that this 10 get compared with the 50, and 50 is shifted right. Okay, then this 10 get compared with the 40, and 40 is shifted right. Then the same 10 get compared with the 20, and the 20 is also shifted, right? And here 10 will be placed in this 5. So here you can see that this t4 is found to be 3. So that in in every iteration, actually more precisely you can write it like this is found to be I can just add one more value, just like why this one, because one comparison I have to do with this 50, and another comparison I have to see in that while loop. There are two cases checked, right? Whether I am reaching the leftmost position of the array as well as this one. So this comparison is happening first between that 50 and 40. Then after making it towards right, next time this will be there. In the previous, in the first iteration both I will do, but in the second iteration this condition will be failed. Accordingly, I will come out from the loop. Okay. So that fail case also one more comparison involved. Okay. So that is what I want to. So more precisely here you can add 1. So similarly here also this t3 get compared with 40, 50, then I greater than 0, that comparison will also happen, right? So that here also there will be one more time, and finally here also there will be something like one more time. So what I can tell is like what I find is like t2 is equal to 2, t3 is equal to 3, t4 is equal to 4, like that. In every iteration, depending on the value of j, I'm getting that many comparison towards end of the array, towards the beginning of the array backward. Okay, so in general I can say that this tj is equal to j. Okay, so this is the conclusion I want. So this is the worst case scenario where tj is equal to j. Now in this equation, here you can substitute j is equal to 2 to n, tj is equal to j. Okay, so you will get like this, and when you expand this, j is equal to 2. So you will get a series like 2 plus 3 plus etc, 4 plus etc plus n. Sum of first n natural number, n into n plus 1 by 2. Okay, now out of that the first term is missing, so you have to subtract it. So you will get like this. Okay, so that is already written. I don't have to write it again. So that so this sum is actually this one. Okay, fine. So similarly here it is tj minus 1 or j minus 1 will come. So when you substitute like that, j equal to 2, it will be 2 minus 1, 1 plus 2 plus 3 plus etc. Final iteration when j is equal to n, it will be. So the sum of first n minus 1 natural number, so that it will be, instead of n you have to write n minus 1 into n minus 1 plus 1. So n into n plus n minus 1 by 2. Okay, so these are all some basic mathematical formulation which you are supposed to know already. Hope you know it. Fine. So that about it. So accordingly I got these two expression I can use now. So just write this first 3 terms, then c5 into this n into n plus 1 by 2 minus 1. Here it is n into n minus 1 by 2 here also. Now you expand and group all the terms having this n square together, and that you can do yourself. Okay, n together and the remaining constant terms, and finally you got that some set of constants, you got a constant there by 2, like that, some expression. So altogether it's a, you can replace it with a single constant, say a. So the entire thing you call as a. Okay, so this is your a, and the whole thing you call as b. So a n square plus b n plus some another constant c. So like that you can write this expression. So something like this, the whole thing you can write like some constant a into n square term, some another constant b into n, plus this minus I am taking inside, so that plus some another constant c. So like that. So now it is a quadratic function of n. Okay, so it's growing as a square. In the best case I got the running time of the best case running time of insertion sort as a linear function of n. Now I got the worst case running time of the insertion sort as a quadratic time function of n. Now this also typically we approximate this further like order of n square. This constant smaller term, everything we will ignore, and this is something called order of growth, and that we will look in separate set of videos. So that time I will tell you the exact reason why we are writing so. Okay, so for the time being, so this is something how we are doing the analysis. Now let's quickly see the sorry, this is not a worst case. Quickly see the worst case we already seen. average case analysis of the insertion sort. So average case, typically it's not so straightforward, and most of the cases in textbook and all we will focus only on the worst case scenario, and we will see why it is so. And sometimes we will mention that best case also. Average case, typically we can take like average of best and worst, but that is not the right way. So here let's just get a feel of how to do this average case analysis of insertion sort. Okay, so suppose that we randomly choose n numbers and apply insertion sort. On an average, I don't know what kind of input. In the best case, I understood that when the input is already sorted, it is giving the best case running time as number of comparison is reduced a lot, and worst case it is reversely sorted, right? But on an average, the input can be anything. It can be already sorted, reversely sorted, or something in between. So that is why some random sequence of n numbers is taken. So one sequence I taken another. So like that. Now how long does it take to determine where in the subarray? So in every iteration, I assume that from 1 to j minus 1 it is already sorted. In every iteration that is getting incremented, and the ajth element, that is in the key value, I am trying to insert at the right place in the subarray which is already sorted. Okay, and that right place we already seen in best case, with a single comparison you are fixing it at the right side, and in the worst case you keep on doing all comparison, and finally you will place this at the beginning. Okay, so in the best case, to fix this a of j at the right place in from a of 1 to j minus 1, in best case you take tj is equal to 1. With a single comparison you were able to fix it, and in the worst case you find out like you have to keep on doing comparison until you are reaching the leftmost end, so that this tj is equal to j. Now on an average we don't know where we will stop. Okay, so we can assume that on an average this tj could be j by 2, somewhere at the middle. Okay, so the best case plus worst case by 2, like that. Okay, some j by 2 number of comparison we are doing for every random input. Okay, now on same formulation you can take, and everywhere tj you substitute like a j by 2. So you will get something similar to this only, because only a constant involved, right? That j become j by 2. So accordingly everywhere some extra constant will involved, and finally there will be some n square term, n term, and constant term. So this will also look like the worst case analysis only. Okay, so mostly best average case is getting very closer to worst case, except some few cases. Okay, so that about it. So the resulting average case running time is turns out to be quadratic, just like the worst case running time. So that you can see, you can just substitute that tj is equal to j by 2 in that expression, and you group like n square term, n term, you will get an some set of constant and an n square term, another set of constant and an n term, like that. So altogether it will also be a quadratic function. So here what the conclusion is, the best case running time of insertion sort, okay, or the best case time complexity, best case running time, and that time or taken, or that difficulty level is what we call as the complexity. Okay, the best case time complexity of insertion sort is found to be order of n, I mean some linear function of n. So that is the way, this is not a right notation. And the worst case running time of it is found to be some quadratic function, and average case is also found to be some quadratic term. Okay, so even though I written like that, don't read like that. Now it's a linear function of n. Here two cases I got a quadratic function of n. So that about it. So the three types of complexity analysis for insertion sort is what we done here, using that step count analysis in a very systematic and formal way. Okay, so that about it. Now let's conclude with one more small subtopic. This you can some spelling mistake. Importance is what importance. Okay, importance of the worst case analysis is something, and this question I saw in some of your previous question paper also in 2015 scheme. Yeah, so why this worst case analysis is giving some more attention over other cases? Because most of the cases in textbook, by default when somebody is asking you to analyze an algorithm, it's enough to give the worst case analysis. But in the question paper, if it is more specific, like what is the best case complexity or average case complexity, and that time you should explain exactly what that one means. So simply if I am saying like a worst case analysis, Yeah, I mean, by default, the analysis, I mean the worst case analysis. Okay, so it's enough to focus that. So let's justify that also why it is so. Three reasons are given mainly. First thing is the worst case running time of an algorithm gives an upper bound. Okay, always you have the guarantee that the algorithm is not going to take some time more than that, so you are safe. Okay, but if I'm telling you the best case, that is something very rarely it will occur. Most of the time, it will go for worst or average case, right? Like that average also, so it's always an upper bound of the algorithm. So you can see that the bus case complexity is something like the lower bound of the algorithm. Okay, so you can also call it as the lower bound complexity, lower bound of the algorithm, or the minimum time taken by the algorithm for a particular specific input. It's not always for any input. And the worst case is found to be an upper case, so it is we are always happy, like the algorithm is not going to take some time more than that. So that kind of a upper limit we can tell, that is on benefit we are having. And accordingly, this average case is something known to be the tight bound, because it is almost a more frequent measure, right? It is in between best and worst. So knowing it provides a guarantee that the algorithm will never take any longer time. Okay, so that about it. So that is the first point. Now, second point is, for some algorithm, worst case occurs fairly often. So in some certain application, you can see that most of the time the worst case is getting happening. So for example, say a searching operation in a database for a particular piece of information, the searching algorithms worst case will often occur when the information is not present in the array. So and you can see that some application searches for the absent information is found to be frequent. Okay, in that case also we are very much happy if we are doing worst case analysis, because the application by default 90% of the time the worst case is occurring. So if you know correctly how to do that worst case analysis, it's okay. So worst case is not going to occur at all, because always we want to search an information which is not there in the array. So but rarely we may get some cases where the array it may be in the array also. Okay, some 90% of the cases it is not there in the array, some 10% it may be there in the array, but we don't know exactly whether it is there or not. So you have to go through that. If it is linear search or something, you have to go to the linear scan of the array completely, then only you will understand. So that is the worst case scenario of searching, right? Okay, in the best case, it is at the beginning of the array. Element to be searched is at the beginning of the array. Worst case, it is at the end of the array, or it is not there in the array. So that kind of an application I am having. So mostly worst case is occurring. So worst case analysis itself is enough. I am happy with that. Okay. So it is giving the upper bound as well as the second benefit. And the third one, the average case is often roughly as bad as the worst case. So this is something we already seen. In this example itself, the average case is found to be n square. So this is something you will see in most of the algorithm. We are seeing average and worst case are almost same. But I am not saying that average and worst case are same. They are equal always. It will change also, but mostly it is happening like that. So it is enough to have the worst case analysis. So three reasons or justification we can say why this worst case analysis is preferred, or it is something the default analysis. To always give you the upper bound, and some certain application the worst case scenario is occurring most frequently, and average cases found to be sometimes it is roughly as bad as a worst case. Okay, yeah. So it's slightly a lengthier video, but a very good content or topic we covered here. And that analysis of insertion search, insertion sort is something a very frequently asked university question also. And this last one also some 3-4 mark you can expect. Okay, so yeah, that about it. Thanks for watching. Of course, doubts will be there. You can ask me during our live class. We will discuss. Okay.